They will be moderating this panel discussion. I request Vipin Yadav to initiate the panel discussion.
Thank you, sir.
Vipin ji, your voice is too low.
Thank you, sir. Am I audible now?
Yes, sir. Yes, sir. You are audible.
Good evening, everyone. I am Vipinkumar Yadav, PhD Research Scholar, Civil Engineering Department, SNIT. Today, I'll be acting as a moderator in this open forum panel discussion, which is second session of day 4 of 5 days online Gyan course on spatial analysis for water resource modeling and management. A warm welcome to all the invited guests for today's panel discussion. We understand that water management requires active involvement of the government through policy making, the engineers by implementing appropriate practices, the researchers by seeking solution to the field problems, and the public who are end users and objective for the whole effort. In order to make this discussion comprehensive in terms of participation of all stakeholders, we have panelists representing government, water management organizations, academicians, and practicing researchers, and us, the users. In today's discussion, we'll be exchanging 3 perspectives. We'll have the opinion of experts having field exposure to advanced practices and studies undertaken in developed countries like USA. We'll have the views of experience and research of experts for solution implementations for problems encountered in Indian region. And we will have curious knowledge seekers and future water managers, that is participants of this Gyan course and other invited guests. Let me take the honor to introduce our water passionate panelist today. We have with us Dr. Sanjay Jain from WRS Division NIH Roorkee, Dr. A.H. Lohani from Surface Water Hydrology Division NIH Roorkee, Dr. G.L. Asawa from SNIT Surat, Dr. Dhruvesh Patel from PDPU Gandhinagar, Dr. R.N. Sankhua, Chief Engineer, Ministry of Jal Shakti, Hyderabad, Dr. M.B. Joshi, SSNL Narmada Gandhinagar, Dr. Santosh G. Thampi, NIT Calicut, Dr. Rajiv from IIT Kharagpur, Dr. T.A. Eldo from IIT Bombay. Other invited guests will be joining us shortly. We thank all the panel members for joining us today. Considering the constraints of time, we'll be having a short discussion on each point for about 4 to 5 minutes. After the point in question has been read by the moderator, the experts are requested to share their views about the point directly by switching on the mic or raising hand to facilitate the order of speaking. Subsequently, the house will be open for the queries and inputs from the participants. The discussion will be bifurcated into 2 parts, in which the first is points of concern raised by the foreign expert will be taken up, and secondly, the challenges and concern for Indian region as highlighted by researchers and practitioners from India will be discussed. At the end of the discussion, the course coordinators will propose a conclusive summary of the discussed issues. We'll start with the first, the issues highlighted by the foreign expert in context of Indian region. The existing infrastructure in many parts of the world, including India, is inadequate to cope with the extreme hydroclimatic events mainly attributed to changing climate. How hydraulic design is evolving under non-stationary climate. So this is the first question raised by the foreign experts. I invite all the invited members, panelists, and students subsequently to raise their views, to share their views. You can unmute yourself and start speaking.
So could I please share my views?
Yes, sir. Please, sir.
Yeah, so from the perspective of Central Water Commissions, I would like to put some points over here. So particularly in hydraulic design and continuing this DPR preparation and all that, it's already common that to assume that the statistics of the variables of interest are constant over time. Generally in designs in Central Commission, we assume sometimes while FR or DPR are prepared. Under this assumption of stationarity, we expect in the future to experience events of similar magnitude and frequency to the ones we experienced in the past. So generally we take 40 years data, 20 years data, sometimes it is not available. Based on this notion, the concept of the return period of a particular event is defined. So as you know all those things. No? So however, many studies in Central Commission and particularly in NWDA, they have shown that this assumption can be insufficient under climate variability because in some part of the Godavari basin, some part of this Krishna basin or Kaveri basin, this varying lot. So climate changes are there, anthropogenic activities are there. So hence it's a matter of high urgency due to this potential risk it imposes on human life and all that. So to incorporate the concept of non-stationarity in hydraulic design, we intend to do that, but still we are missing somewhere in the design part. So sometimes these potential changes in the pre-boat, sometimes putting up these dams, particularly road concrete dams, the failure risks in a warning climate calls for a improved design concept that will consider this potential changes in the extremes over time. But we fail to do that. However, incorporating this non-stationarity in design concept is a challenging task. All the times we do not get this correct concept on that, and requires not only the model development but also an adaptation strategy. This non-stationary extreme values analysis, like we are using NEVA software in NWDA, and which utilize this extreme value theory framework and this Bayesian inference in parameter estimation, but that also goes wrong many times. But still, we get certain return level return period curves under stationarity and non-stationary assumptions. But in Central Commission design that SC that CM did and all that, they are also trying this way. But most of the cases we are succeeding because whatever values we get, those values we incorporate in the design and put it forward for this implementation of this ILR projects. So that's what I do. And definitely this hydraulic design is evolving under a non-stationary climate change thing. And we are also adapting to that, and slowly we are marching forward in Central Commission and also in NWDA and preparing and getting this ILR projects implemented in India. So this is my view about this non-stationary climate change and the hydraulic design sort of thing.
Thank you, sir.
Myself, Sanjay Jain from NIH Roorkee. Just I will say one or two aspects in this, and Dr. Lohani is here from NIH who is working in flood. So first thing I will say that with climate change, rainfall intensity, as we know that it is increasing. So instead of going for more physical measures, if we can increase the infiltration, because intensity is increasing, so we have to see how we can increase the infiltration so that we can handle that floods which may be generated because of this climate change. And we have to have some regional studies as well, and of course hydrologic design we have to change or modify according to the climate change which is occurring. So this is just I was thinking, and Dr. Lohani, if you can add something to it.
Okay, thank you, Dr. Jain, and thank you, Dr. Sankwa. Dr. Sankwa and Dr. Jain, as they have mentioned that regarding the hydraulic design. So if you see here, a number of projects are being taken up by the different organizations. Like if you just see under DRIP also, DRIP dam rehabilitation program, the one important task is that to review the design set of major and medium dams. So we can see that now with the revised design set, the Hirakud Dam, they are increasing the spillway of the Hirakud Dam. So likewise, if you see that regarding in the past few years, as Dr. Jain has mentioned, that because of the climate change, the rainfall has changed in some of the areas. So we have to take care about those things, that well as that we talk about the non-stationary thing in the climate. So we have to take care, and more studies are required to carry out. So now if you just see, instead of going for, Dr. Sankwa has mentioned that the length of the data. Length of data is one thing is very important, but we have to look forward when the fast change has taken place in the rainfall pattern. So if we are concentrating for that data itself, so that will give a much better picture. If you are going for a very long data, when the change in the rainfall is not that much fast, so that might give some misleading results. So we have to take care for the selection of the data. So these are the few important things one has to take care while going for the uh, uh, especially design for distribution for, under the climate change scenario. So this is just my submission for the gathering. Thank you very much.
Sir, this is Santosh Tampi from NIT Calicut. I just want to add to what Dr. Sankhwa and Dr. Jain mentioned regarding the incorporation of non-stationary climate in hydrologic design. I think we have a long way to go. Right now, as far as I understand, non-stationarity aspects are being studied, especially with respect to precipitation. But it is mostly confined to academic realm, and in order to bring this into practice, I think a lot of work will have to be done before we may be able to do it. That is one thing. And even the Hirakud Dam division, design flood division, which Dr. Lohani was mentioning, I think the non-stationarity is yet to come in there. It's basically because of the revision in the methods of estimation of design flood that this increase has happened. The other thing is increasing infiltration, which Dr. Sanjay Jain mentioned. I think it can have negative effects also. It has to be done after looking into the hydrogeology, the geologic setting in which we are. For example, if you look at the floods, the landslides which have happened in Kerala, many of them have been triggered because of excessive soil moisture in the soil. So I think that would actually require a region-specific approach. We cannot actually generalize. Maybe for Indo-Gangetic plains this may work, but I think for especially if you look at geology of states like Kerala, it can have disastrous consequences, especially in the hilly terrains.
So here few things as Dr. Tampi just pointed out, so I would like to mention that. So recently we had a project in Karnataka, that is Yatinal project, which is almost 95% implemented in field. And we had a project in Karnataka, that is Netravati Hemavati Intelligent project, which was not agreed by state government earlier, but now they are agreeing. They want that to be extension to that. Anyway, so my point of telling is that whenever we take up that Netravati Hemavati or that Yatinal project as a whole, as an extension part of that, what we faced actually, we did not have data sets, as Dr. Lohani was mentioned, that we did not have data sets which can at least tell about this climate change impact, how does impact over the last 20 years, 30 years or 40 years. But when we took the data for 40 years, that gave some other series. When we took data for 20 years, that gave some other series. And the climate variability or the impact of climate variability over in the region, that was quite sort of erratic sort of thing actually. Some part of Karnataka was quite dry, and these parts which are dry for 40 years earlier, so these areas are not dry now. So while planning this Netravati Hemavati DPR, we faced a lot of difficulty in that. Sorry, PFR, we faced a lot of difficulty in that. And while implementing that Yatinal project, when they asked us regarding this Yatinal project details hydrology part on that with consultation central commission, we faced a lot of difficulty in taking this stationarity and non-stationarity data into account, because the length of data was not available, first thing. Number two, the correctness of data also could not be ascertained, because state government sometimes they do not measure, sometimes they measure. Central commission may not have adequate stations over there which can measure data. So these sort of these uncertainties are there in data analysis to have this implementation of the project. But still, it is implemented almost 95%. But still, we are thinking that Netravati Hemavati, if it is extended for this ethanol project with that hydrology, whether the climate impact has been taken into account fully or not, that is not understood fully now. So I do not know about future, but definitely there is one necessity to have this non-stationarity of climate change impacts to be incorporated in the studies of this implementation of this hydraulic projects, which are too costly to implement. So this is my submission about this.
Thank you, sir. So we'll conclude this point here and move on to the next point.
Okay, I also have one more point to raise. Am I audible?
Yes, sir. Yes, sir. You're audible.
Okay, so actually non-stationarity, the main issue is that now whenever we are doing most of the designs, generally we use the based upon IDF curve designs, most of the designs we do. But now with so much of non-stationarity issues are coming up, now we need to do, so the uncertainties in all our design has been very much increased. So that way the design is concerned, hydraulic design is concerned, we need to see the uncertainties, what is involving, and then maybe instead of simply depending upon IDF curve, which is generally we do 50 years or 100 years of rainfall data, and then getting that 10-year return period or 100-year return period, like that, we need to do further uncertainty analysis, and then that has to be put it, and say for example, like a 2018 Kerala flood or whatever what is happening in Uttarakhand or maybe regions. So that kind of uncertainty issues to be put it, and then typical analysis to be included in all our hydraulic design. So that is very much important under this non-stationary condition. So that is what is my suggestion. Okay, thank you.
Thank you, sir. So we now move on to the next point. Rainfalls exceeding commonly used intensity design frequency based design standards are becoming more frequent over the many regions. What are the future directions for changes in IDF curves in the Indian context?
So in this point, I would like to mention that adaptation of the renewal of this IDF class must be incorporated, but it's almost incorporated by IMD in the design the procedures to reduce the vulnerability of existing and new infrastructure projects. So as you know, the India has been divided into 7 zones and 26 hydrometallurgical homogeneous subzones. Homogeneous in the sense that IMD assumes that it's a homogeneous subzones. So out of the 26 hydrometallurgical subzones, so for computing this design plot for a specific return period, they have divided into parts. What they do when they calculate this rainfall extreme series for return periods, so they use 3 methods. First method they use the ID method, ID curve method. Second they use the PMP by the standard method, statistical methods. Third one they use the isopluvial map method. So either they take data from this ORG ordinary rain gauges, they take data from SRRG, that is standard recording rain gauges, or they take data from this HRA, that is rainfall points. Rainfall points, they are having around 36 stations. Within that, they have many substations over there also. So why I'm telling this, because this RMSI designed one PMP atlas from Central Commission for Hydrogen at the cost of around 8 crores, where IMD was requested to give the data and all that. So they have been very extensively helping us in taking up this GIS maps for this atlas, PMP atlas and all that, which is also available in PDF format in this NET. You can get it in NET and get it for that also. So IDF code, though it has not been renewed by individual organizations, but still IMD, they have renewed it, they have adopted it, and they have given it to CWC for development of the PMP atlases, and that has already been taken care of, updated also some 4 years back, and that we are using for designing of the hydrology structure of that. So that already indirectly or directly that has been already taken care of by Central Commission of years ago.
Thank you, sir. I would like to invite Dr. Dhruvesh Patel, sir, to fill up on this particular point. Dhruvesh, sir, are you able to hear me?
Yes. So we are discussing for this particular, or either I move to for flood assessment, you are saying? I not heard your question. What you say?
Sir, I wanted to have your opinion on this point, sir.
Okay, for rainfall exceeding commonly use intensity, duration, frequency based design standard become more frequent over the many reasons. The future direction for change in Indian context. Yes, I am in favor of we have to change that, which I had the experience for like in dam break analysis and all. I have seen that IDF will not have the adequate IDF for the flood assessment. So in that prospect, I would suggest here that yes, we have to revise. Yeah.
Thank you, sir.
Yeah.
Ms. Aarti has raised hand. Ma'am, you can unmute and you can speak up.
Good evening to all the experts. Myself Aarti from SSNL Surat. I would like to ask to the experts that in context of non-stationarity, as the question suggests that future direction for changes in the idea of curves. Under the non-stationarity condition, whether a research scholar or students seeking in this direction the research, should they go with the city-wise non-stationary development of idea of curves? What the expert will suggest, whether the study should go city-wise or basin-wise, the non-stationary intensity, duration, frequency curves.
I would like to listen Aldo sir.
Okay, so in this sense, say as I mentioned, the uncertainty is always a problem. And then one more thing is that idea of curve generally, say for example, regional wise will not have much meaning in whenever we are looking to the floods. Floods are concerned, it is now very specific areas. Like now you can see that due to cloudburst or that kind of things are happening in many regions. So that way we need to see that, say for example, when you are taking a region.
Vipin? Hello.
Yes, sir.
I think sir has lost connection.
Yes, sir. So if any other expert has to say anything about this point. All right. So thank you, everyone. We'll move on to the next point now. Precipitation extremes.
In this last question, what this that lady asked, questions, I would like to say that don't go for basin wise, because basin wise the data will be more erroneous, because basin is quite big. So the 20 basins you see in India, basins are too large in sizes. So if you take sub basin wise, it's okay. Otherwise, if you are going for city size, it's okay also, no problem. But don't go for bigger sizes, because taking the data for those bigger basins would be difficult for you to handle, and also the uncertainties will be much more. So better go attack these areas which are smaller in sizes, either sub basins or watersheds or city areas which you feel better.
Thank you, sir.
Thank you, Dr. sir. So now next point is precipitation extremes, both in terms of magnitude and frequency, that contribute to catastrophic floods are evaluated by many studies around the world to understand the influence of climate change and variability on these events. How is climate variability driving the nature and magnitude of floods and their impact in India?
So I would request Dr. Mukesh Joshi to share his experience at SSNL. I request Vipin sir or either Rashmi to show his slides that what happened during last Narmada flood. Dr. Vipin sir or Rashmi, please share Dr. Mukesh Joshi's presentation.
Okay, sir.
This is a very good example, exactly how it's happened in case of Narmada, that Dr. Joshi is going to explain us.
Thank you very much, Professor. And at the outset, let me congratulate the organizers, because a very interesting and important discussion is going on here regarding the climate variability, and particularly with reference to the floods. Let me share, our experience at Sardar Sarovar project, which is one of the largest human endeavors of our times, so far as, integrated river basin and water resources development is concerned. We have in Narmada basin, Narmada river is the 5th largest river in the country and the largest west flowing river of the country, where cascading reservoirs are there. Next, please.
Vipin sir, change slide.
Yeah, please change.
Sir, slide has been changed.
Oh, no, it's not changing.
I'll share again, sir.
climate change is a reality now, and it's no more a rhetoric. And we have to consider, in all our planning exercises, design exercises, and operation of, major reservoirs, major dams, we need to consider this aspect as an intricate component. And I have just, prepared a few slides which will show you how, this was quite helpful during, 2019 and 2020. Because as you all are well aware, the dam has a long history of, more than 7 decades. And yeah, now it is available. Yeah, thank you. So kindly, move one by one as I, tell you.
Yes, sir.
Basically, this is the map of the Narmada River Basin, which originates from Amarkantak in Madhya Pradesh and traverses through, Madhya Pradesh, and then, partly through Maharashtra, and then in Gujarat. So the total length of the river is 1,312 kilometers, of which 161 kilometers is in the state of Gujarat. Now, when the integrated planning and development of the Narmada Basin was conceptualized, it was envisaged that 30 major dams, 135 medium dams, and about 3,000 minor dams will be constructed in this basin on river Narmada and its tributaries. So far, about 14 major dams have been constructed, and we will talk about it in the next slide. Next, please. So these are, the major dams which were envisaged, and out of that, 4 major which we can talk about right now is the Indira Sagar project or Narmada Sagar project, the Omkareshwar project, the Maheshwar, and then Sardar Sarovar project. So Sardar Sarovar project on river Narmada is the terminal dam so far as, flood control and flood management is concerned. Next, please. Major dams, and if we talk about the travel time, Bargi is another major dam, and it takes about 16 to 18 hours time to reach to Barhanghat, and then from Hoshangabad, then it is Indira Sagar. So the distance between Indira Sagar and Sardar Sarovar project, if we consider, it takes about 21 to 34 hours, the travel time for the flood, and the distance is 50 kilometers between Indira Sagar and Omkareshwar, then another 45 kilometers between Omkareshwar and Mandleshwar or Maheshwar, and then 224 kilometers. So the N-1 dam, which is called Maheshwar, is about 224 kilometers, and Indira Sagar is even larger than the Sardar Sarovar project in terms of its live storage capacity. So it is available at around 320 kilometers. Next, please. Now, this I have tried to present the live storage capacity of these 4 major dams which we are talking about. Bargi on the right hand side, if we talk, that is the upstream most Bargi, and then Tawa and Indira Sagar and Sardar Sarovar. So Sardar Sarovar, if we see the live storage capacity is 5,760 million cubic meter of water, which is around 50% of its annual water requirement. So the storage capacity is not huge here. Indira Sagar, as compared to that, has 9,745 million cubic meter of live storage capacity. So the point which I am trying to drive here is that to address the climate variability and the floods occurring because of that, we need to operate these reservoirs in an integrated manner so that the flood effects in the downstream can be minimized and the water wastage can be reduced to the extent possible. Next, please. 97.5% catchment of the Sardar Sarovar project is in Madhya Pradesh. So we are not, really affected by the rainfall which occurs in the state of Gujarat, but we are mainly affected by the rainfall intensity in the basin, which are shown here with that yellow color. 2016, it was, quite green. It was a surplus year. And 2017, you can see it was a water stressed year so far as Narmada Basin is concerned. Next, please. Downstream effects are to be minimized because in the downstream of Sardar Sarovar Dam, there is a major city which is Bharuch city, having about 3 lakh population. And then there are tributaries also which are meeting in the downstream. They are meeting the main river. So we need to operate Sardar Sarovar project spillway gates in such a way that the overall impact in the downstream is well within the control, because that will be further, added up with the tributaries flow like Karjan and Ursan. Next, please. Everybody knows about this, but just I have tried to juxtapose these two pictures. For 7.5 years, the dam construction was stuck up as at 121.92 meter, which is the spillway crest level, and we had an uncontrolled dam available. So we could not, regulate anything so far as flood is concerned. So in an ungated situation, this is how, the 2017 flood took place. You can see on the left side of the screen. And on the right hand side, after, the dams were put in place and after we had received the permission for closure of the gates, we could, regulate the flood with the help of these 30 radial gates. Each, is capable to negotiate a flood of about 1 lakh cubic. So total spillway capacity is 30 lakh cubic. So in the year 2019 and 2020, for 2 consecutive years, the dam was filled right up to the full reservoir level. Next, please. Key issues and approaches that we have adopted. The first and important is defining rule levels for all major dams in the basin. And pre-depletion may also be required, in some cases. Now, this pre-depletion may, in a way, help for hydropower generation, because, say, for example, Indira Sagar project is also, having a huge hydropower infrastructure available, and Sardar Sarovar project also has 1200 megawatt riverbed powerhouse plus 250 megawatt canal head powerhouse. So we can use these 2 powerhouses, generate hydropower, and pre-deplete the dams with in consonance with the flood forecasting or rainfall forecast which are available, particularly with the help of this climate variability models. Implementation of real-time data acquisition system that we have implemented with the help of Narmada Control Authority and Central Water Commission. Then synchronization with hydropower generation, which I have talked about. And the bottom line here is water is immensely invaluable, precious commodity and need not be allowed to go waste. Next, please. So with this, I would like to, just thank the organizers as well as all the participants, and would like to underscore the point that under the climate change conditions, we need to evolve our own strategies and models to help integrate the operation of the reservoirs. Thank you very much.
Thank you, sir, for the wonderful information you have shared with us. I would like to invite views on the point we have been discussing. So if any expert want to say anything on this particular point, you are welcome, please.
So in this point, I would like to just tell a few things. That whether the extreme precipitation changes have a relation with the seasonal cycle for water availability, so that is not clear as yet. So we are getting papers, we are getting researches from IITs, ISC or some other organizations from outside also. But we are not able to explain the things beyond that. But with the projected precipitation and the temperature, that changes, that imply that the possible changes in flowers, although there is a low confidence in projections of the changes in flower flowers. Look at that. I mean, confidence is also too low due to this limited evidence, and because of these causes the regional changes in our complex, which are also difficult to understand about that. So there are also few expressions to the statement, but what I said, but still we get that sort of problems here. Since many extreme events such as those associated with this precipitation occur rather at small control and spatial scales, the climate simulation skill is currently limited and local conditions are highly variable. So projections of the future changes cannot always be made with a high level of confidence because of the data which are getting from researches from these academic institutions, from the research institutions and other things. And when you take in consideration for this implementing projects in real field, so we are getting this difficulties are always there. And understanding the relationship between the climate change impact on the extreme events and the water availability, that is most essential, because while getting the water availability, for example, I was telling about Netra Dhamma project or ethanol project. So that was more a condenser because water was not available. Karnataka government was trying to have the project extended further. So that is also that understanding the relationship between this climate and water availability, that is not clear as yet also. That also future proof to planning also, that we may not be sure to ensure a sustainable socio-economic development in the regional states, particularly maybe in Karnataka, maybe in Maharashtra or some other areas. So that is what we are facing. So there may be some changes. We are getting some evidence that there is a climate impact. We are getting some data and we are getting some research papers. We are getting some other things. But with high level confidence, the projection for future changes cannot be made. What I mean to say. So this is my point of observation to make it in this manner.
Thank you, sir. We now move on to the next point. Are there any research studies that are undertaken in India to understand snow runoff generation mechanisms and rain or snow conditions that lead to catastrophic floods? So I think we have already covered this topic in the lecture of Dr. S.K. Jain. So I would like to invite Jain sir to open the comments on this particular point.
Yes, Mr. Yadav, we are doing a number of studies for snow melt runoff. In that, as you know, that the temperature is the major cause for snow melt, and we are taking the snow melt from April onwards. In addition to temperature, we have also included rain which is falling and transferring heat to the snow, and because of that, rain melt is occurring. So that also we are considering in computation of this snow melt. But no study as such we have carried out where we have seen that because of this rain melt there is any kind of flood. But as we have seen in the Kedarnath event in 2013, there were heavy rainfall during those 2 days. Maybe you remember that on 16th and 17th, and today it is 16th only. So 9 years back, a heavy rainfall occurred, and because of that, there was some kind of snow avalanche was there. So that piece of snow fallen into that lake, Chorabari Lake, and there was flooding. But it was mainly because of the breaching of that lake. So we have done number of studies on breaching of lake because of various regions, maybe means if there is any breaching. So hydrodynamic modeling we have done, and then we have seen the flooding and flood values at different points we have computed, and flood inundation maps have been generated. But as such, I cannot say that because of rain melt there is any condition that lead to the catastrophe.
Okay. Can I add a few things to that comment?
Yeah, please.
So in United States, mostly the problem we have in the upper reaches of different watersheds, for example, the Mississippi River Basin and so on. This is a common problem where you have the snow accumulation, and all of a sudden the temperature changes to, sometimes positive temperatures that will start melting, and then if you have a rainfall event. So that has led to many catastrophic floods. And when the forensic analysis was done, why we have such a large flood and what was the reasons? So most of the time the reports came back and said that these two phenomena for that extreme flood generation, and there are other cases also which have happened in the past. So there is some amount of strong push for from the agencies, especially the federal management agencies, emergency agencies, to look for this particular phenomenon so that they can have more active monitors in the field, and so that they can develop more effective forecasting methods, so that they can warn the people who are living in the flood zones. And this is one of the research areas, especially in the Northeast, where we have a huge amount of snow accumulation over the winter. And once in a while, because of this temperature changes, we do have these conditions happening, and then that will lead to tremendous floods. And the other comment I would like to make is, Dr. Joshi, your wonderful presentation. I would like to see if agencies in India has started looking into more real-time forecasts, in the sense when we say real-time, couple of days, and then of course short-term in terms of 5 days or 7 days. So in US, there's a different levels of forecast that has been offered for reservoir operators, especially a 3-day, 1 day, and then of course 7-day, 15-day, based on numerical weather prediction models, so that they can start planning things. Now a new concept I was discussing in the course, it's called the forecast informed reservoir operations. It's called FIRO approach is also there, which they have been adopting. And especially in California, we have these atmospheric rivers which cause a tremendous amount of water drop or precipitation. And that is again a factor which they would like to forecast in advance. In terms of the climate variability, the forecast is more focused on the phases of El Nino or La Nina, and seasonal forecasts are more important for us because that can help us in see how much water is coming into our reservoirs. Especially some parts of the United States is going through a drought now. So this will have a more impact on whether a particular phase we will have. For example, right now we are in La Nina. So the forecasting models can help us know whether we will continue to be in La Nina or we will continue to go back to a neutral state or El Nino state and so on. So my question to you is, what kind of advanced forecasting techniques India is using in one of these largest reservoirs? When you have these connected reservoirs, how are you managing them?
Thank you very much, Professor, for your interest in Sardar Sarovar project. As I said, Sardar Sarovar project is an interstate project which is governed by an independent body which is Narmada Control Authority, and Narmada Control Authority is supported and continuously cooperated by Central Water Commission. So Central Water Commission provides us.
Okay. Yeah. Sorry.
So Central Water Commission, they provide us forecast for next 24 hours, next 12 hours, and next 6 hours, as you rightly said. And then we have our own stations which also provide us additional information what is exactly happening on ground. And we deploy our staff on duty round the clock 24/7, so that we are definitely taking decisions which are well informed decisions, and the decisions are to be taken in consonance with other operators of the dams. So for example, there are upstream dams which are operated exclusively by the government of Madhya Pradesh. They are not interstate projects, but still we need to have continuous dialogue with them, continuous interaction with them during the flood time, so that in a synchronized manner we can minimize the wastage and we can harness the flood for the betterment of the people. Thank you.
Thank you.
Just I have to add here. Yeah, I have to add here that the question was that the flood forecasting in India, as mentioned by the Central Water Commission, is giving the flood advisory, 3-day flood advisory. They are forecasting the floods for various major rivers. They are also forecasting for the inflow of the reservoirs, and very recently for two of the reservoirs, two of the places like Bakra BBMB has developed a real-time decision support. They are also utilizing a decision support system to utilize that inflow just to manage the floods in the downstream side and utilize that forecast values. And another real-time decision support system has been developed for the Upper Krishna Basin. So Maharashtra is utilizing that real-time decision support system. So that also basically forecasting the inflow into the reservoir, then they are managing the flood in the downstream side. So these are the two important studies very recently they have taken up, and they are working fine. And very recently, National Institute of Hydrology, we have also taken up a study. We are planning to develop some models to forecast the inflow of the reservoir using the satellite database. Okay, so we have already tested this one for 2 of the reservoirs, and we are planning it to just confirm our modeling and test our models for different reservoirs, means 5 to 7 reservoirs across India, so that we can just tell that how accurate or how accurately we can forecast the inflow for the reservoir. So that for that the reservoirs authorities can use those data sets, and we have also got some requirements from the Gujarat also. They also asked us to develop these kinds of the model, means the satellite-based model for the reservoir inflow forecasting for some of their reservoirs. So this is just for update.
Yeah.
Thank you, sir.
I just want to add one small point. In many systems in US, many reservoir management agencies, they are using ensemble stream flow forecasting methods so that they can quantify the uncertainty based on the ground conditions, based on the numerical weather prediction models, based on what is expected as a quantitative precipitation forecasting to the future. So they're combining all these things and they are providing the operators or the management agencies with some kind of an ensemble so that the uncertainty in the stream flow forecasting can also be used to a certain extent to operate the reservoirs. So I hope similar efforts are going through in India.
Yeah.
Okay.
Yes,
Thank you. Thank you so much, sir. I'm sorry to abruptly hold back since we have time constraints within the format of the Gyan course. So, and we have some more points to discuss.
Sure.
Though it has become immersive, but we would have to rush to the new points. So the next point is updated probable maximum precipitation estimates in many regions of the world are not available due to several reasons, which includes funds to support studies. What is the current status of PMP estimates for India in different regions, and what are future plans to address the improved estimates of PMPs? Would like to invite short discussion on these things, sir. Again, I would like to remind, sir, since we are rushing to the time, we'll move on forward quickly, sir. Thank you, sir.
So under this, I would like to say a few things on this. In this, you can get these maps and this PDF format like that CWPRS Corporatin under MP-atlases. You can get this map, but still updated PMP atlases have been prepared on GIS platform by RMSI and Central Commission, and is available in hybrid data. And this covers all the relevant details such as the pattern of key storms, along with their synoptic situations, observed rainfall statistics at various stations, return period of rainfall at various stations, spatial temporal distribution of rainfalls. Apart from the grid-wise PMP estimate for the quick and direct assessment of applicable PMP or SPS forecastment, so these are available in Central Commission hybrid data. The grid-wise PMP is given in the atlas that can also be used for quick assessment of applicable PMP SPS, as I said, forecastment. However, such assessment should be limited to small and medium catchments because we go by small and medium catchment and add up those things. So these are available in India, updated also. So we can use this sort of data. Anyone who wanted to use this data can take it from hybrid data of Central Commission. This is available.
Thank you, sir. So if there are no other views, we'll move on to the next point. Considering recent floods due to intense short duration precipitation in Indian cities, climate change impacts on urban drainage systems can be reduced by using green infrastructure for both mitigation and adaptation efforts. What efforts are underway to address this situation? I would like to invite Eldo, sir, to give some input on this particular aspect, sir. I think he is not able to hear us. Yes, any other expert who want to comment on this particular point, sir?
Yes, Vipin. It feels that the Indian cities and with the existing storm drainage networks, they are not catering with the short duration intense flooding, short duration intense rainfall, and hence there is a need to check green infrastructure both for mitigation as well as adaptation efforts. But presently, except few cities, I think Sankwa sir, Bangalore, and I think Chennai, these are the two cities wherein probably they are taking up with some urban solutions, stormwater solutions, which will help to mitigate the floods which causes because of short duration intense rainfall.
Thank you, sir.
Sir, your microphone is mute.
Yes. So see, in Hyderabad and Bangalore, so because I'm frequently visiting the cities for this thing, So here in GMC, that is Greater Municipal Corporation of Hyderabad. So what they're doing? So they just are needing this people's views, because understanding the people's views on impact of climate and adaptation options, that is crucial for prioritizing effective policy responses in the face of climate change and all that. So green infrastructure they're trying to implement in Hyderabad, but they are not so successful. And because GI is also valuable for climate mitigation, as everyone knows, through its carbon storage functions or by returns and sales, they were trying to have this formable payments in some parts of the Hyderabad and Bangalore also. And green roofs are not at all present here. And rain barrels, one or two places here, but lake, Oceans are lake, they are just placed recently, maybe 2-3 months back. But this is not so efficient in Hyderabad. This is not so paramount here in Hyderabad, because people's views are more important. And Bangalore also they are trying to have that, because of the traffic congestion and all that, they are not doing that much. But still they are trying to have this, because this willing to pay, people's willing to pay for GI, that also matters in this. So this willing to pay concept in Hyderabad and Bangalore, that creates a hindrance for this GMC and Bangalore Municipal Corporation to come this, take this issue on. So last 6 months back, we had a meet with the commissioner of the Bangalore Municipal Corporation, and we have discussed on this, and I was invited also by GMC Hyderabad. So regarding this, there is not much data on this, and there is no information effectively which is available in Hyderabad or Bangalore. But still they are trying, GMC or BMC, they are trying their best to have this GIs implemented, and they depend on the people's views and all that.
Thank you, Sanko sir. Maybe we can have the view from Dr. T about this on his perspective.
I think the green infrastructure and other adaptation methods are going on in different US cities. Even there's resistance for that. Also, there have been in many cities, the zoning laws have been violated. So people constructed in places where they are not supposed to construct because of whatever business interests are there. So what they are doing is they are generating this concept of livable cities, and that attaches to transportation, infrastructure, and water. So in that case, what they are doing is they're trying to buy some areas in heavily urbanized, populated areas, buy land, and then start creating this green infrastructure so that you can store the water temporarily, at the same time infiltrate the water faster, and so on. So Pittsburgh is one of the examples where they have achieved some success, and this is being continued in different cities. So we are moving towards improving that so that we can reduce the effect of flash floods in many US cities, which is a common occurrence these days. Thank you.
Thank you, sir. So definitely a way ahead to tackle the situations in a more resourceful way. So we'll now move on to the next topic. Approaches that consider incorporation of GI for stormwater management, performance evaluation of existing urban drain systems, and adoption of emerging technologies to assess low impact development are required. How Indian cities are making headway in improving forecasting systems, urban stormwater drainage networks, and other initiatives to address floods in an evolving climate.
Yeah, I think the question is similar to what we have just gotten views from experts. I think the one question is that is there any move towards improving the storm drainage network? That is one question. And the second question is that the forecasting is very important, especially for urban areas, because that will result in flash floods, a tremendous amount of damage. So is there any improved forecasting methods or forecasting centers that have been established for some large urban cities? Are they using radar based techniques to estimate the precipitation amounts, to have some feel of where the storm is heading, all those things? But I think that the two-part question is, one is is there any reevaluation of the existing urban drainage networks? Are they trying to improve them, rehabilitate them, increase the size of the networks, reduce the the plastic pollution is the main problem in many of the storm sewer systems. Are they using some filters to make sure that the plastic is not obstructing the flow of water? That's the question.
Sure, I'll share my experience of city of Surat. What mostly all Indian cities are passing through this stage only. What I observe in case of Surat, that initially with the expansion of city and with heavy rainfall, lot of low-lying areas as well as some other areas were getting flooded. So the first task of the local authority like municipal corporation, what they were doing, what they have planned, they have put efficient stormwater drainage system such that no part of the city get inundated more than 15 to 20 minutes, even if there is a heavy rainfall. But as far as the extreme short duration rainfall is concerned, the design is such that which may not be economical or which may not be affordable for many of the corporations or many of the cities of the world, and therefore the problem persists when there is a short duration high intense rainfall. Otherwise, for normal intensity rainfalls, almost in all the cities of the India, we find that the inundation which was happening before 5 years back, now we are not observing. So that much improvement is there, but the improvement from the point of view of short duration extreme precipitation, probably that is a need of the hour.
So in this, I would like to just add some point on this, because in Chennai they have taken some measures, because Adyar River, so that was covering plots in Chennai in 2015 and all that. So what in January 2021 and further, what they have done, that Chennai Mega City Development Mission and Integrated Stormwater Dam Project and Smart City Project all combined together, they have thought of the things. They have gone further ahead. They have planned their way ahead also. They have been doing the things for the 8,835 drains spanning an area of 2,051 square kilometers area. And Chennai, they are having a smart forecasting system with the help of this ISRO, so that they are getting the things beforehand. And the waterlogged areas, to be waterlogged areas, they are also finding out beforehand. In 2022 plot, I hope that Chennai won't get that much plot as it was getting earlier. So they are doing these things. So now people are on the verge of taking the technology in their hands to advance further, particularly flood forecast in drainage areas of Chennai and all that. As Professor Yadav told about the Surat city, the Chennai also, they are taking for mega stars. Even Hyderabad also, this GSMC Hyderabad also has taken some of the good things with the help of ISRO, NRSC, and they are also going ahead for this plot to not to get impacted by the areas in the areas. So they are also going ahead. So in Chennai, they have gone much ahead, and Hyderabad also they are trying their best to go ahead of this. They're trying.
Thank you, sir. Dr. Jess.
Sir, your microphone is muted. Jai Kumar.
Is it okay?
Yeah, sir.
Yeah.
Okay.
Yeah, in fact, though a lot of studies have been carried out in India, especially in the aftermath of Bangalore, Chennai, Mumbai, Delhi floods, the implementation of the stormwater drainage system is lacking. And the maintenance of stormwater system also is lacking. Now, in India, if you see the average rainfall, number of rainy days is only about 60, 70 days in a year. Remaining 300 days, we don't have rainfall. So all the drains are filled with garbage. And when actually it starts raining in the month of July, June, July, there is no capacity in the drain, though the drains have been designed, take into account all these details. So the operate maintenance of the drainage system is what is lacking, though a lot of studies have been carried out across the country. Even now, you find a short duration high intense rainfall causes floods, even though they've got excellent roads, the drainage system is bad. So, what we do in a city like Warangal, where I live, we request the municipal commission, in fact, at our NIT Warangal, we write to them that to get all the drains clean in the month of April, May, we do it as a war footing. So this is one of the cities where it has not been flooded. So it's actually the construction is one aspect, design is one aspect, but more problem is the operation and maintenance of the drains. Yeah, Dr. Yadav.
Yes, sir. Yes, sir.
Yeah. So that is what
rightly pointed out, and therefore, as Professor Joshi will agree with me, that most of the major cities of Gujarat, they take up pre-monsoon activity. And under the pre-monsoon activity, mostly they are trying to clean the stormwater drains, so that make them ready to receive the runoff from the roads. Yes, Vipin, shall we
Yes,
move
sir.
ahead
Thank you,
to
sir.
the next point?
So most of the topics which are going to be put up in these challenges faced by researchers and practitioners in India, they have been extensively discussed in the foregoing discussion. So we'll be moving on to the next point and quickly move forward. So some of the topics which have been mentioned, or points which have been mentioned by Dr. Dhruvesh Patel, I'll just read out the highlighted points, the problems which he has faced, and I would request Dr. Dhruvesh, sir, if I miss out on any point, he can add on.
Sure. Thank you so much. First, I would like to thanks to Professor Yadav to organize such a very important STTPs for the researchers, professors, and all stakeholders, where we have seen that the major parts covers the major area of the hydrology, hydrodynamic, hydraulic modelings. I have been working, especially in the limited part, I say that especially on flood modeling only. And I have observed some of the important points which come out from the research, where actually it required to do efficient research in flood assessment and management. So the first and foremost point which I have observed for doing any hydrologic and hydrodynamic modeling, more or less we required the high resolution DM. So how the researchers receive or obtain the high resolution DEM for fluvial or either the fluvial flood modeling. So I feel that this platform is now open for the discussion, that many eminent professors and researchers and the government officers are here. They can support the researchers that how they can get the high resolution DMs.
Dr. Patel, I would like to say something on this aspect. We are also facing the same problem.
Yes.
We have done HECRAS or bike level modeling, and then the flood inundation map, if we have to prepare, then we don't have this high resolution DM. We are having one project that is called as National Hydrology Project. It is a World Bank aided project under our Ministry of Jal Shakti, in which this task has been given to Survey of India. Means they are developing high resolution DM for some of the stretches or some of the streams. The area along Ganga, they are producing a submetric DM for that rain. For other area, it is not submetric, but it is very high resolution DM which they are developing, and it will be available by March 23. So recently there was a meeting of NHP in Gandhinagar, and they have with the advanced LiDAR approach and other approaches they are applying there, and they are producing that high resolution DM. So this will be available. This is one thing. Like what we did in one of the study is we improved our DM with the help of some observation from the field, and then we improved up to some extent. As we know that vertical resolution is having an error of 7 to 8 meters, so which is not applicable to such studies, but up to some extent we can improve with the some technique, but we cannot get submetric with those techniques. So LiDAR survey and other survey which Survey of India is doing, that is the only, I think, technique to produce that level of DM.
Yes, yes. This is really very important, and I came to know from you. Thank you so much, sir, that LiDAR techniques are now going to implement in India and covering some part of some.
Most likely, those DM will be available in public domain.
Once they are open source DM.
Open source, yes.
Yes. Thank you so much, sir. So the next point I would like to discuss is about the major constraint is model calibration and validations. Most of the case, small hydrologic or hydrodynamic models are validated and calibrated by help of the observed gauge discharge data. Scanty data sets are available, which are located on our rivers. And because of these reasons, that again it hampers to we say that validate our models and produce the robust results for flood hazards and flood vulnerability mappings. So what we do or we can do in this case, that how we get the precise observed gauge data, gauge discharge data.
As Dr. Jain has mentioned, under HP, now India WREMI is also one of the medium to just disseminate the data. So all the data which the Central Water Commission is just observing and the various states are observing. So right now, for the unclassified basins, except Ganga and Brahmaputra, the data are available from the India WREMI. One can download the data. So most of the researchers, they are downloading these gauge and discharge data from those sites and utilizing those for their research purpose, MTech and PhD uses. So these data are mostly
Sir,
from
it is
the Central
available
Water
for
Commission.
all major
India WREMI is the site.
But the problem here in India is that so that is available for 20 kilometer square area only for research purposes free of cost. But once subbasin comes to bigger size, so that becomes difficult for researchers to get the data for bigger subbasins or that. So these sort of problem was also faced earlier. So now also they are facing the same problems. So this was discussed in Ministry of Jal Shakti maybe 1.5 years back, but that was not accepted too. But still the same problem persists. But now what they are doing, the data validation part of Central Commission is not that up to date because they are trying to do that because of shortage of manpower, shortage of the technical skills and all that, technical personnel and all that. So they are not able to do all the part. Water book is published every year, but still we are having some sort of data validation problems. In southern part, I am talking about Godavari, Krishna, Kaveri, Penna, all those rivers. But this validation part by the secondary validation, particularly the secondary validation part by Central Commission is still lacking because of this shortage of personnel and all that, because there are not requisite level of personnel involved in this. So that becomes a problem. And WREMI does not give data more than 20 kilometers per hour, as I said. Another thing that I would say, like to say that, like Dr. Lwani said regarding Ganga and Brahmaputra and Indus, these data are available, but these data available, that will be big time taking because 4 months, 5 months through ministry, directly through commissioner here. So commissioner that data, so they will be giving data. Commissioner Ganga and something like that, they will be giving data. That takes time. And the regional chief ministers are in charge of this data and they can give the data to these researchers provided this data is not classified one. And that too, the GND data can be available from this site offices. And CWC, the surface data center, which is maintained at CSMRS particularly, so they are having the data. And on payment of some sort of amount for particular sites, the data is available. And for other data sets, you can approach the regional offices and the executive in charge or director in charge can release data with the permission of the chief concerned. So this is available, GN data is available. But the only thing is that for classified data, that takes some time because that goes to ministry and the concerned commissioner approves that. So that has some limitations in this. Otherwise, data sets are available. Even within 1 day also it's available. Recently, the 3-4 days back, we had data for 20 years. I got it within 1 hour. But up to 2021, we got validated. After 22 May, we did not get validated data because that takes time for validation purposes. Because running this SWDs, then HIMARS, then setting data, so that becomes a heavy task for this personnel engaged. And the personnel are very less in number, so that becomes a problem for us also.
Thank you, sir.
Yes.
I would like to request all expert members who have access and idea about various reliable data sources to put the sources in the chat box. For the benefit of running out of that, I would like to move on to the next point. Dhruvesh, sir.
Yes, please. Sometimes the researchers are difficult to get the data from the government offices. And because of hampering to receive those data, they cannot produce the quick flooding or flood analysis. So what we can do in this case, that how we quickly get or available the data sets for
See, in this case, I would like to pinpoint that this nail is not hammered at the proper place. Right? That causes the delay. If you approach one junior engineer or assistant engineer or engineer, they cannot give the data to you. And the data should be immediately requested with proper format and everything should be in place. That should be sent in email to the concerned officer, who is in charge of that. Maybe not even say, I'm talking about Krishna, this Godavari, Krishna, it is sent to this KGPO, Hyderabad, who is Mahanadi, Eastern Rivers Mahanadi. And people, what we are seeing that even many data requests are coming to me, which I am not in charge, but still that coming to me because they think that I am in charge of that. Likewise, so that proper mail should be hammered at the proper place. So then only you can get the data instantly. And maybe I tell you that whatever data is available, that can be disseminated within 1 day time, not much more than 1 day. Definitely within 1 day, because data sets are available. That is in computer, that is in Excel format, and you need to request the person. So who is in charge of data, and definitely will get the data in time. Sometimes it is getting delayed because the request is made to another person who is not possible the data. So that becomes a problem for this. And regarding classified data, the data has to be made in proper format. That will take 4-5 months time. As I said, because that has to go out to the ministry, and the commission in charge will be giving the permission for that.
Thank you, sir. I would like to invite attention to all the participants that the question being asked and the answers being provided by the government representatives can be useful source of information to procure reliable data for all the research work. So
Yes.
I would request Anil sir and Jay sir if they have to say anything. All right, thank you, sir. Sir, your hand is raised, that's why there is a confusion. Ruvesh sir, can you move on to the next point?
Yeah. Yes. I go quickly to the next point. Post-flood survey. Now I have a couple of experience for validating the model which I have set on Surat as well as recently to the Rail River catchment, Dhanera city in Banaskantha district, Gujarat, India. So most of the case when we are going to validate the model by help of the observed HFL level, I have observed that in city area, they have marked it with the red line or red color, where it shows actually the indication of high flood level. But along with one, I'm going to validate my model's outcomes of the model with the observed data. Then I found that it has some scanty informations in form of like the locations in form of latitude and longitude, and another one is to the depth or maybe that the RL of that marking which has marked on the wall, or maybe that some remarkable locations. So I have suggested here, but what we do collectively to improve that data sets in future.
So your past flood survey, I would like to tell that, and I was in charge of Krishna Basin, Godavari basins long years back. So every year we do that survey, and every year that HFL marking is there. Though we are not using this method GPS drone sender, now we are using that. But earlier those days in Krishna Basin and Godavari basin, we were using that survey, general theolite survey, and we were having the marks, blue line marking, red line marking. These markings are available in major rivers in India. That will be available to you all the time.
Along with the latitude and longitude, sir, right?
Latitude, longitude, almost every time it's available because we have TBMs everywhere, all the basins, sub-basins, ready-made available. But think is that where you are going and where you are approaching.
Sir, yes. Sir, one more experience.
Now at present, I am heading the southern region, particularly 8 states, all southern states plus Gujarat, Maharashtra. In every river you tell, we have the TBM data. So that is available with the regional engineering office, so that can be available to you.
So, one more question in that whether we have any specific grids where how apart those marking should be have in different areas.
Specific, I could not follow your point. What was the point actually you are telling?
Point is that, sir, suppose we have marked this red line on some building, how apart the other marking will have in the flood affected areas.
Yes, we have, like in Krishna Basin, I tell you that in this Krishna River, the Koyna River, we have this blue markings, red line marking. Red line means HFL unprecedented product, those markings are there, and also buildings, permanent buildings we mark sometimes. In Sangli area, in was the city, I forgot, Kolhapur area, and those areas you mark it, those are permanent government buildings and all that. And that's markings are available to you, and this data can be made available from this local union office or union office or SSNL office, or particularly in union office will available. In all these areas is available. Think that you have to go there and request for the data. That's available.
Yes, thank you, sir. I would like to stop the discussion over here since we have run out of the time. And I'm thankful to all the contributors who have shared their questions with us. We are not going through the individual questions given by researchers like Surna and sir, because most of the points we have already covered in the discussion. Now, I would like to invite our coordinators to answer the questions written in the chat box or the participants might be having. Should I read out the questions?
Vipin, sir, you can take one or two quickly.
Okay.
I think most of them are very good suggestions they are providing to the discussion what we are having. I think the main problem even in fully developed countries like United States, the data is a big issue. Having the right amount of data at the right time for us to both calibrate and validate is a big problem. Sometimes we don't have data. It is a fact. And then, even though there's a tremendous amount of money invested in improving the topographical information, in the sense improving the DEM resolutions, going for LiDAR data, that has been slow. It is progressing in some parts very fast, some parts very slow, but I think we are getting there in terms of improving the topographical information so that the flood modeling will be much easier in many parts of the country. So, but definitely the data quality has been improving in the last 10 years. And unfortunately, the data is also available to the public. Anytime a government agency takes up a project for improving the data, that data is available to the public. So any researchers who are working on any topics related to floodplain modeling, flood management, flood forecasting, or simulations, they have access to this data. That's one good thing about the whole process.
So there is a query, suggestions by Dr. Asava, sir. I'll just read it out for you, sir. There have been very good comments by the expert as for the estimation of the effects of climate change on the hydraulic parameters and the resulting flood are concerned. However, it seems there has been no discussion on the root cause of the climate change as well as floods, which is obviously the huge and ever increasing population of the world that the world has to support. Since one of the stakeholders is the government, the population issue needs to be considered and addressed properly. I think, sir, that's a very big thing to deal with, and government only can think about it.
No, I think I can answer one small, my opinion. I think population is a social problem that government cannot address that, but trying to develop real zoning activities, trying to see what zones can be developed, what zones cannot be developed, green infrastructure, urban network design, improvement of forecasting facilities, and then also a dedicated centers for climate change and climate variability impacts in different sectors of the country in terms of agriculture, tourism, or any other factor that is affected by climate variability or climate change. I think if the government can do all those things, and they can at least address or help the population in taming the climate change impacts, or at least handling the climate change impacts, reducing the catastrophic floods, hazardous floods, and save people. In many instances, having a better forecasting model can save thousands of people, and of course, infrastructure also. So social problems, that has to happen at a cultural level. The culture has to change. But I think the government can invest on some of the things what I have indicated, so that we can improve infrastructure. We can improve protection to infrastructure in many cities and many towns in India.
Thank you so much, sir. Since we have finished the time for this session along with the question time also, and we can see that the discussion was getting warmer.
Okay, sir. Rajiv sir want to say something. Yes, sir. Yes, Rajiv sir.
Yes, sir.
Yeah, sorry for the last moment. Actually, just one small addition what Dr. Ramesh has told regarding the population, which is definitely one of the big challenge for everything that we are thinking of, not only for the flood and also for the I should say that exposure to the climate change. So what I feel is that is definitely true that we have to take the government as one of the stakeholder. At the same time, it is a social problem. It is very difficult and big question. But what I also feel that the research should be oriented to identify the exposure of the climate change effect in terms of our society also. Means including the population exposure to the climate change. That is one of the thing that we can think of maybe as a way forward from this meeting, which I just want to add what Professor Ramesh told to that one. So that is one of the potential domain in this one. I just want to add one more thing also, particularly for the Indian context. What sometimes we feel that we, the researchers, we do some sort of, we get some result and we keep it within ourselves, and we sometimes I should be equally blamed. I'm not saying that there is no system. I should be equally blamed that I don't approach to the government. You see, I have this one. For example, a small example I was just looking through. For example, the probable maximum precipitation. We have recently done one work which is basically assessing the revised PMP under the changing climate for India as well as for the globe. So that one is already published, and once we publish, fine, I feel that my job is done. So I don't approach to the government agency. For example, I am just listing out some of my recent ones. So I'm just pasting one just for the reference here. So this may be one which is giving some sort of estimate from that what could happen in future. Should we change the PMP estimate as a graded base? So that kind of thing. Maybe we can take a step from here, how we can link the researcher and the government agency more strongly, so that it is not that we are always begging to the government for the data. It is also that they also want the real-time research output from our end. So there should be some mechanism to joining hands so that we can also offer them our research output directly to them in a real-time manner also, so that they also feel enthused and encouraged. Yes, I'll get this one in return if I supply the data. Just a small thought to share with you at the last moment. Thank you.
Thank you so much, sir. Now we would like to conclude the session. I thank all the invited speakers on behalf of organizing committee to spare their time and give their valuable suggestions and insights and experience with our upcoming water resource managers. And I'm thankful to all the participants for bearing with us for this prolonged time. Further instructions will be given by others.
All the experts are requested to turn on their camera, and I request Rashmi to take photographs of all.
Yes,
and we use it for Gyan portal submission. So please turn on your cameras, and I thank all the experts who have spared their valuable time for a discussion on such an important topic. Thank you so much.
Thank you.
Rashmi, I think she left. Ayushi, you take.
Yes, sir. Yes, sir. It's done.
Okay, thank you.
Sir. Okay, thank you, everyone. Thank you so much.
Thank you.
Okay. Bye, everyone.
Bye. Great to see all of you, especially Dr. Asav. I'm seeing him after a long time.
Sir, you unmute yourself.
Oh, yes.
Asava, sir.
I am seeing Dr. Sanjay Jain and Dr. K.V. Jayakumar after a very, very long time.
Yeah.